Hello everyone, welcome to week 4 of Codivate Python class. Our topic for today is user input and conditionals. Let's get to it. Okay, so so far in our Python class, we learned how to print text to the console. Now we're going to learn how to ask the user to enter something in the console and then store and use that input. This concept is known as user input. So here is the syntax for user input. Let's break it apart. We use the input function, just type in input all lowercase, and then we have our two parentheses, and inside those two parentheses, we want something to appear onto the console, and we write that as a string. Here, usually if we have input, our string will be a question, or it's going to be asking for some type of information. In our case, we're asking for the name of the user. When we run this code, the question will appear on the console on the right side of the screen. And the cursor, as you can see, will be right next to our input. Then we'll be able to type anything we want onto the console. For here, example, I typed my_name. We could type anything. Then once we press enter, we are done entering our input. So here, since we're only taking input and we're not really doing anything with it, nothing else will happen besides just exiting our code. Nothing will really happen by doing just this. Now, if we actually wanted to do something with that input that the user gave us, we have to assign it to a variable. Here, we take the input that the user gave and we store it to a name variable. So what will happen is whatever the user enters in that line will be stored as a string inside the name variable. We can use that variable later on. Here we're printing hello, followed by whatever the user entered. Let's take a look at what happens when we actually run this code. So I'd run the code, it would say enter your name. And then as a user, I would type in your_name. And what the next line of code does is it will print hello. And then we're using concatenation to take whatever the user entered and then print that. As you can see, it is a string. We didn't have to do any typecasting, so that works. So the key thing to remember here is that whatever is taken in by the user input function, it will always be a string. Even if we enter a number, for example, like 1, 2, 3, it won't automatically think of it as an integer. It will think of it as the string 1, 2, 3. Right? So what if we didn't want it to be a string? We wanted to take the user input as a number and then actually do some math or some numerical operations with it. What would you have to do? So the solution for this is to use typecasting. So if we weren't going to use typecasting, this is what would happen. We would have num, we're asking the user to enter a number, and then we are going to square the number. So if we try to square the number, we get this type error. It basically tells us that we can't square a string and an int. And the reason why it's saying that is because num, which is a user input, is a string. So num here is a string, and we're trying to square it. Just a quick reminder, the double asterisk means raised to, which is just exponents or repeated multiplication. So using what we know about typecasting, how do you think we could fix it so it actually prints our number squared? You can pause the video and play it when you think you have an answer. So the solution is pretty simple. We go to our second line print statement and we change this num and we put it inside an int and then a parentheses. This is casting it as a num, so it will actually be seen as a number. Now we can test this code out with the updated line, and we see it works as we want it to work. We type in the number 9, and what happens is it goes into here, into the num variable, and then we go to this line. So right now, num is the string 9, but since we're making it an int here, it becomes the integer 9. And once it's an integer, we can do things like square it. So it squares it. 9 squared is just 9 times 9, which is 81. Alright, let's move on to our next topic for the day, which is Boolean expressions. So before we get to conditionals, it's very important to learn Boolean expressions because they form the basis of our if statements. Booleans are a data type that evaluates to either true or false. That's what we learned a couple of weeks ago. Boolean expressions will also evaluate to either true or false, but they're a little bit more complex than just true or false. They're actually an expression that evaluates to true or false. So some expressions that evaluate the true or false are comparisons of numbers. So the signs for comparisons are the same for less than and greater than. A is greater than B, A is less than B. But if we are checking for less than or equal to and greater than or equal to, having this sign appear on the keyboard is pretty tough to do. So what we'd have to do to make it easier for Python is use less than followed by the equal sign or greater than followed by the equal sign. And this just indicates A is less than or equal to B or A is greater than or equal to B. A few more things. If you want to check if two numbers are equal to each other, what we'll have to do, we can't use one equal sign since we use that if we want to assign something. We'd have to use two equal signs. Here we're using two equal signs. So what this would do is it would return true if A is equal to B and false if it is not. So I'm just gonna go back and review like what all of this actually means. So let's say A and B are two numbers, or it could actually also be two strings. But checking if a string is greater than or equal to another string is not always the most useful thing. So we can think of A and B as maybe two different numbers. Let's think of them as 1 and 2. If A is 1 and B is 2. var is being assigned 1 is less than 2. Well, 1 is less than 2, so that is true. So var is being assigned true. And similarly, 1 is less than or equal to 2, that's true. But if we say 1 is greater than 2, that's false, so this would become false. Let's take a look at the last one, which is not equal to. So the exclamation sign in programming means not equals to. So if you wanted to check if two different ints or two different numbers or two different strings, they are not equal to each other, we would have to use this exclamation equal sign operator, which will return true if A and B are not equal and false if they are equal. These are just the definitions of all these operators. I think it will be a bit more easier to understand if we look at some examples. Let's take a look at our first one. You can pause the video and based on what we just discussed, predict what you think this will print. Once you're ready, you can press play. Alright, so let's go step by step. In the first line, A is being assigned a value. What is it being assigned? It's being assigned the result of the integer 9 plus the integer 10, which is just 19. B is being assigned 21. So remember, A is 19, B is 21. What we're printing now is A equal to B. What we're basically checking is this variable A equal to this variable B. And it's going to check the values. So 19 is equal to 21. Well, that's false. So that's what's going to print. If this happened to be something like 12, then it would print true because 21 is indeed equal to 21. Alright, next topic for the day. Or not next topic, next subtopic. And, or, and not. If we have more than one condition we want to check, we can use these operators, and, or, and not. For a statement that involves and to be true, both conditions must be true. For a statement involving or to be true, either one of the conditions can be true, but it requires a minimum of one of the conditions to be true. For not, what not will do is it will negate the condition after it. It will flip whatever is after it. So if the condition after a not is true, then it'll make it false. And if it's false, it'll make it true. Let's get some practice with some examples. B is being assigned two Boolean expressions that are combined with an and. The first expression is 5 is greater than 4, and the second expression is 5 is less than 6. What do you think this will print? Alright, so we know that 5 is greater than 4, so this is a true Boolean expression. Now let's evaluate the other side. 5 is less than 6. Well, that is also true. So if something is true and this other thing is also true, we know that both of them are true, which makes the entire Boolean true. Let's try an example with OR. You can pause the video and come back to it. Alright, so I'm assuming you had a go at it, and we'll go over the answer now. So now we have an OR. At least one of these conditions must be true for this to be true. The first condition, 2 is equal to 3. Well, we know that's not true. 2 is not equal to 3. So this becomes false. Let's check the other one. 0 is not equal to 0. Well, 0 is equal to 0, so that's also false. So since none of these are true, and we're looking at an OR operator, it's false. As you can see here, at least one condition must be true, and it is not, so our output is false. Alright, last one. So what's happening here is we are starting out with a false, and then we just put a not in front of it. So as I said, think of not as negating whatever is after it or flipping the value. So since it has a false here, and if we do not false, well, if it's not false, it has to be true. Think about it like that. So we don't necessarily have to use like the word false. We could put another expression here, and then it would make the expression the opposite of what it actually is. So here, since we negated the false, it becomes a true, and that is what is printed. Now let's get to a very interesting topic, which is called short circuit evaluation. So when it comes to evaluating Booleans with and or, there's a principle in programming that the computer uses to evaluate these expressions efficiently. And this principle is called short circuit evaluation. Let's say we have two Boolean variables, A and B, and we are checking A and B. So we're checking if both of them are true. Alright, so there would be four possibilities in this case. Both of them are true. A is true, B is false. A is false, B is true, and both of them are false. So if we go through each one of these, let's see whether or not we actually have to evaluate both of them. So if the first one is true, we have to at least see the next one, because if depending on this value, A and B could be true or false. So if they're both true, it becomes true. And if one of them is true and the other one's false, it would become false. But if the first one happens to be false, we know, well, it's not even possible that this is going to be true. So why even bother evaluate the second one? We can just directly conclude the entire thing is going to be false. So that's what computers do. Let's take a look at an example. Before we go over this example, you can predict what you think this will print. Pause the video and resume when you're ready. Alright, I'm assuming you predicted what the outcome was, and we'll go over it together now. So, we have to remember, short circuit evaluation with AND is looking for a false value, because as soon as it sees a false value, the entire expression with AND becomes false, because we need everything to be true, this one and this one. So we have a Boolean mystery here. It's being assigned 5 is less than 4. Let's try to evaluate it as if we are the computer. Is 5 less than 4? Well, that's false. Oh, I see an AND here? That means this entire thing can't be true. And that means the mystery has to have a value of false. And we are done. So let's print it. As you can see, that is our output. One interesting thing is that even if we have some condition that causes an error here, obviously we can't divide by 0. 0 divided by 0 doesn't exist. It will just ignore that because of short circuit evaluation. On the flip side, we also have short circuit evaluation with or. Unlike and, we're looking for a true value now. So as soon as we have one true value, we know that the entire or will be true. So if the first one is true, we know the entire expression must be true. If the first one's false, we have to keep checking and check the other condition just to make sure if it's true or false. All right, let's do an example with this one. You can pause the video and give it a go. All right, so the answer for this one is true. Let's take a look at why. Let's evaluate it as a computer. Mystery is being assigned a Boolean value. The first part of this Boolean expression with an or is 3 is less than or equal to 3. Well, 3 indeed is less than or equal to 3. It is equal to 3. So this part becomes true. And since it's an or, we don't even need to look at the next one. So we're done, and we print true. Once again, we have a division by 0 error going on here. So we might think that it would cause an error, but short circuit evaluation prevents this from happening. There is one last concept that we're going to review when it comes to Boolean expressions. Before we go over it, let's just define what an iterable is. An iterable is anything in Python we can loop through or iterate. Iterate is just a synonym for looping through. We don't 100% know how to write loops yet in Python, but we've worked with iterables before. A string is an iterable. We can look at the letters one by one. Lists and tuples are also iterables. We can loop through each item one by one. So if we have something that looks like this, item in iterable, this is actually a Boolean expression, and it will return true if the item is in the iterable, and it will return false otherwise if it's not in the iterable. Let's take a look at an example with lists. We have a products list that has a few strings in it. We're making a Boolean variable called isTherePhone. We're assigning to it the string phone in products. So what's going on here? What happens is that we check, is this string phone inside this list called products? Well, yep, it's right here. So this evaluates to true. So this becomes true. It's being assigned to this variable, and we print that variable. So our result is true. Now we check, is there a tablet? Now we do the same thing with a tablet string. I don't see any tablet in this list. So that means this Boolean would get the value of false, and if we were to print it, it would be false. Just one thing to remember, usually with naming things, we start off with something like is, and then we check, like we make the rest of it based on what the Boolean is doing. It could be are if we're checking for multiple things. For example, are there tablets? Then we would check if there's like more than one tablets. We would change this Boolean expression to check for more than one tablets, but that's something a bit more advanced. Let's get some practice with writing Booleans. Here's the first one. Write a Boolean that returns true if some variable n is a multiple of some variable k. You can pause the video after I read each one and then try to come up with a solution on your own. Alright, let's go over the solution for the first one. So this one is pretty simple. What we want to do is basically check. If n is a multiple of k, we know that k has to be a factor of n, right? So if we want to check if something is a factor of something, how do we do that? Well, if some number k is a factor of n, we know that if we do n divided by k, the remainder would be 0. Well, how do we check if the remainder is 0? We use the modulus operator, and we just have to compare that with 0. So we're just basically checking n modulus k equals 0. So this is a very useful thing. We could check for divisibility and factors. Second one, we have to return true if a list is not empty. So we want to make sure that there's at least something in this list. And if there's not, we return false. Pause the video. Alright, the solution for this is to just check if the length of the list is greater than 0. Since the length of the list will give us how many items are in the list, and we want to make sure that it's at least 1, we can just check, is it greater than 0? Because if it's greater than 0, there has to be something in that list. Now, our next one, write a Boolean that returns true if some variable x is between -32 and 212 inclusive. So it can be -32 and it can be 212. All right, you can pause the video and we'll go over the solution. Okay, so for this one, we can't directly do something like -32 is less than or equal to x is less than or equal to 212. We can't do that. Python will not understand that. What we have to do is use an AND. We have to check for both conditions. X is greater than or equal to -32, and it's less than or equal to 212. So this is a very useful Boolean if you want to check if something is in a certain range. Our next one, return true if the string absence appears in some list less than 3 times. One hint for this one is the count method that we looked at with lists. You can pause the video and give it a go. Alright, so we'd have to use the list since it's asking for a list, and we're using the list method count because we want to see how many times absence appears in the list. So we use list.count and then the string absence. And what do we have to do? We have to return true if it appears less than 3 times. So we check, is it less than 3? That basically reflects what it's asking us to do in this Boolean. Moving on to the last one. Return true if a variable called answer has a value of yes. You can pause the video. Alright, let's go over the solution. This one is very simple. We are just checking its value using the equal sign. Answer is equal to yes. This was make sure that that the answer variable is storing a string yes, and if that is the case, it will return true, otherwise it will return false. Alright, we made it past the Booleans, and we also learned Boolean expressions, so let's learn about conditionals. Conditionals are used in programs to implement logic. Conditionals are only executed if a certain Boolean condition is true. So an example of a conditional is an if statement. Let's look at its syntax. Let's break this apart step by step. First, we have the if keyword, which starts an if statement. After the if keyword, we have a condition. Here, the word condition is just a placeholder for Boolean expression. We don't actually have to write condition. It's supposed to be a Boolean expression that will evaluate to either true or false. At the end of the line, we have a colon. This is used to indicate that we are at the start of the code inside the if statement. So once we have our colon, the next line will actually start whatever is inside the if statement. Once we write the first line, and press enter, Python will automatically make an indent. And whatever is inside this indent will be executed if the condition evaluates to true. So if the condition were true, then inside if statement would be printed. If it were false, then whatever is inside the indentation would be skipped, and we'd go back to whatever is in regular indentation. Once we go back to normal indenting, we are not in the if statement, so outside if statement will be printed no matter what. If this is true, both of these will be printed, but if this is false, only this will be printed. Okay, let's do some examples with if statements. Alright, you can pause it after each one and then give it a go. Let's go over the answer for this one. Let's replace the condition that we had on our last slide with an actual Boolean expression. Here our Boolean expression is 3 is greater than 2. Well, that is a true statement. So we would print this string, 3 is greater than 2. And also, it would always print if statement complete since that is outside the indentation of the if statement. Even if this were some false condition, it would still print if statement complete. For this next one, you can pause the video and resume when you're ready. If true. So this one might be confusing. You're thinking, where is the Boolean condition? Well, true is the condition. The condition is true. What we're basically saying is we're literally telling Python, the condition is true. Execute it. So if, and then true, print, this will always print. So since this is true, this will always print. Obviously, this is not the most efficient code, but just understand the concept of how we can directly write Booleans will be very useful, especially when we get to loops. And this would always print. This next one, since we directly tell Python that the condition is false, it will never print, it will never execute whatever is inside here, since we told Python this is false. So nothing happens on the console. So here we see a condition that evaluates to true, and since it's evaluated to true, we do whatever's in the indentation. Here, we literally tell Python it's true. Here, we tell Python it's false, and it doesn't do whatever inside here. All right. In the case the condition in our if statement is false, like let's say this condition here is false, and we want to take care of that and say, in the other case, we have to do something else. What we could do is do an if statement with the opposite condition, or we could do it pretty simply with an else. So let's identify the important parts of the syntax. So the indentation of the else has to line up with the if, and there's no condition after else because what will happen is that if this condition is true, it will do whatever is in here. Otherwise, if this condition wasn't true, then it would go to the else. So in our case, if this condition was a Boolean expression that evaluated to true, it would print the condition is true, and otherwise or else, that's what we literally type, what will be printed is condition is false. Let's do an example with if-else just to understand it. What do you think will be printed by this code segment? All right, I'm assuming you had a go at it, so let's take a look. We know the syntax. We are checking if an item is in an iterable, which is in this case is a list of numbers. So we are checking if the integer 100 appears inside the list called grades. Let's take a look. Nope, nope, nope. Oh, it's right there. So, since this is true, it will print there is a 100. And we can confirm that by printing it. So if this evaluates to true, we don't even go to the else. Because this is our backup case. Just in case this happens to be true, we do something else. But since this is true, we just do whatever in here and we're done. Now let's get some practice with if-else. So you can open up a rebel.it tab. If you haven't already, write a program that will ask the user for a number input. And it will print whether the number is even or odd. You can pause the video and give it a go. Alright, I'm assuming you had a go at it. So the first step is to ask the user for a number input. Let's make a variable, num, and assign to it input. This is just what we learned, how to use user input. And we tell them to enter a number. We have to remember, if we want to use it as an actual number instead of a string, we have to cast it to an int. But before that, let's think about this. How would we tell if it's even or odd? Well, what defines an even number? What makes a number even? Well, that's the fact that it's divisible by 2. And we can check divisibility to see if we divide something and there's no remainder. So that's what modulus 2 equals 0 is doing. We take the number, make it an int, so it's actually being used as a number, and then we divide it by 2 and check if the result is 0. So if a number, we can divide it by 2 and the result is 0, there's no remainder, we know it has to be even. And we print whatever the user entered as a num. Remember, this time we don't have to cast it to an int because we can't take an int and concatenate it to a string. And we know that when they initially enter it just as a num, it's a string. So this is a string plus a string. So if it is even, that's what this condition is checking, print num is even. Else, we know we don't have to do another condition. We know that there's only two possibilities, even or odd. So in our else, we have print and then num is odd. Now let's look at chaining if statements. Sometimes we have a lot of cases we want to look at and we need many conditionals. A simple if-else won't be enough. Here I have a code segment that takes in your grade in school and returns which school level you attend, high school, middle school, or elementary school. Try to pause the code and looking at these tested outputs, try to find out what the error in this code is. Hint, it's not a syntax error, but it's rather a logic error. Alright, I'm assuming you paused the video and tried to figure it out. So what's happening here is that we have these if statements here. Let's say we're in 10th grade. The program takes our input and casts it to an int. Let's say 10. Grade is being assigned 10. School is just an empty string. So if the grade, which is 10, is greater than or equal to 9, school is being assigned high school. Well, 10 is greater than or equal to 9, so it's being assigned high school. We go to the next condition, if. Remember, there's no else here, so we do go on to the next condition. If 10 is greater than or equal to 6, our school is middle school. Well, 10 is greater than or equal to 6, so our school is now middle school. Hold up, that's not supposed to happen. But before we address the error, let's actually go to the next line. If our grade 10 is greater than or equal to 1, school is being assigned elementary school. Well, 10 is greater than or equal to 1, so our school is now elementary school. So, as you can see, it would print elementary school. Same thing happens if we tried other grades, 10, 8, or 3, it just prints elementary school every time. That's not what we want. We want to make sure that if the grade is greater than or equal to 9, it should stay at high school. So, one way to fix this is to use if-else. Let's take a look at that solution. On the left, you can see we change the code so that it uses else if. Now, only if grade happens to be less than 9, we go and check should it be in middle school or elementary school. And only if it happens to be less than 6, we go and check if it should be in elementary school. So, although this code works, it will give us the right output, it will take care of everything, and we won't unnecessarily keep checking the grades after we have the right one, or the schools. This is a lot of code, and there's a lot of indentation. It's kind of confusing. You might be wondering, why not just put these else and if on one line? Well, like this, we can't do that, but there's something in Python that makes our life a whole lot easier, and that's the elif. So we can replace the else if with an elif. So instead of saying else if, it's just an elif, and it does the same task as whatever is happening here. Just the indentation is clear, and it does it in less lines. We can test our code, and once we tested our code, it works for all the cases. Let's just go through our code. If 10 is greater than or equal to 9, school gets high school. Else if, or elif, well, this condition was satisfied, so we don't even go to this, and we're done. High school. Let's try grade is 8. Grade is 8 greater than or equal to 9? Nope. We go to the next one. Is it greater than or equal to 6? Yep, it's being assigned middle school. And since the other one's an elif, we're done. And we could try it for many different grades, and for all of them, we'll get the correct output. Here are our exercises for the day. I will pause. You should probably pause this video and try to finish them up, and then check your solutions later. There's 2 slides of exercises this week, so here's the first slide. Here is the second slide. You can pause and rewind just to see them. Alright, I'm assuming you read all the exercises. For the first one, we have to ask the user to input 2 numbers, use 2 separate lines for each input, and print whether or not the second number is a factor of the first number. Alright, let's look at our solution to this one. Num, that's our first number, we're getting an input. Factor, we're getting another input. So we know how to check for factors. We have to use the modulus operator. But since these are strings, we have to cast them as an integer. Okay, so if the first number as an int divided by the second number as an int has a remainder of 0, that's what this modulus equals 0 is doing, then we print that the factor is a factor of the number. Else, we print that it's not a factor. So this is just simple divisibility with modulus going on here, and we're using our equal to 0 to actually check if the remainder is 0. We can test this with a few outputs. So if we enter the number 25 and did another number, 5, it will tell us 5 is a factor of 25, since 25 modulus 5 is equal to 0. 25 divided by 5 is 5, remainder is 0. We're checking if the remainder is 0 to make sure it's a factor. If we did something that doesn't work out, for example, 3 and 2, we know that 2 is not a factor of 3, and that's confirmed by our program. So if we want to test our program, and we have a lot of these conditionals going on, one thing to remember is that we have to test all the cases. Our second exercise, I'll go back, is to ask the user to enter a number from 0 to 100 and convert it to a letter grade A, B, C, D, or F. Let's go to the solution for this one. So we ask them to input a grade, and then we cast it as an int. Since we're working with it as an int, we want to check if it's within an integer range. So our first thing we want to do is check, is it actually within 0 to 100? Did they listen to us? Did they actually enter a valid number? And if it isn't, we're just going to tell them from the beginning, invalid grade, that's it. That's not going to be anything from A, B, C, D, E, or F. Because a grade of 105 or a grade of negative 15 wouldn't really fall within this category. Else, if it's actually in the range, we check, is it greater than 90, greater than or equal to 90? In that case, it would be A. Otherwise, if it's not greater than or equal to 90, but it's still in the range, we check if it's greater than or equal to 80. In that case, it would be B. And we go so on with all the conditions using an elif. But for our last one, since we know that we're in their range, since we've really made it this far, we made it past this condition, and none of these other ones ended up being true, we know that we could just use an else, which would take care of everything that is less than 60. In that case, we just print F. Okay, third exercise. Create a list of school subjects. Ask the user to enter a new subject, and if the inputted subject is already in the list, print that whatever you entered is already in the list. Otherwise, add the subject to the list and print that the inputted subject has been added to the list. So this sounds like a pretty big project. You can pause it and give it a go. We'll go over the solution now. Let's make a temporary, or let's just make our subject list. Has a few strings in it, math, English, science, and history. And we want the user to input a subject. Subject is being assigned an input. Here, since we are working with it as a string, we don't need to cast it as anything. We want to check, did the subject that the user entered already exist in this list? Well, if it does, we want to print that the subject is already in the list. So we check that using the in keyword. If the user inputted subject, which is stored in this variable called subject, is inside this subject list, we're going to print the user inputted subject is already in your list. Otherwise, if you want to add it to the subject, we could just append it to the end of the list, and then let the user know your subject was added to your list. For example, if I ran this code, I enter the subject math, I already have math in here, it would go to this if statement, check, subject is in the subject list, well, it already is, so we print subject is already in your list. Otherwise, if I entered something that isn't in our list, for example, French, it would add it to my list and tell me that it's been added to my list. So that's it for this week. If you have any further questions, you can reach out to us on the Discord. And that's it.